Hello, everyone. Hi, Manu.
Good morning, Mark.
Uh, I know you messaged Davis. I haven't myself talked to him in weeks now.
Okay.
I don't even
I,
have my one-on-ones.
I feel like I'm afraid we did something wrong or that
No,
we are just
no,
pariahs or
you
whatever. It's
didn't.
like,
It's just this
okay,
is, working with large bureaucracy is like that.
understood.
It's
Thank you. I
just,
appreciate that.
yeah, I always tell
Hey,
startups we
Mike,
can remain indecisive longer than you can remain solvent.
that would be literally the case in our situation.
I'm very sorry this is happening, but I wish I had
It's,
something. Okay.
it's all right.
So as soon as we have enough people, Sudar on the call here, he is a colleague of mine,
Hi, Sudha.
recently joined, and he actually has this super fun and enviable task of implementing our ideas.
Ooh.
So I'm hoping once Sudar is successful, we might be able to do an actual demo
So you're
of.
introducing us as people to blame. Is that what the?
No, Sudar will be to blame.
Yeah,
Oh, okay.
It's
It's
very
implementation
clear who's
fault.
on the
Get to
hook.
blame the LLMs.
Good. That's what I like to hear.
That's right. Okay, so but yeah, I can't wait for the day when we have our first workload running, with this code. Uh,
well, I think we should, Sudhar, it's great, welcome, and it's great that you're there. So if we could actually write up the actual demo setup that we want to do, because we may be able to also spin up our own version of it, because we have, I think, pretty much all the pieces. So
yeah,
it might be interesting to do two implementations.
that would be
But
even better if we could.
yeah, but then we,
Yes.
we should really define, the strict minimum that you want to demonstrate, right? Obviously, we don't want to spend a lot of cycles in doing, extra stuff. But if it's basically just, we actually have already, our CTO already built a spiffy workload that is, getting its SVID and its credentials from the mesh from an agent. So there's not much. I mean, it's probably formatting of things that we need to clean up a bit, but the mechanism is already there. So
All
it would be
right.
interesting to get together and just demonstrate that it can be done by multiple companies. So
Okay, so let's dive in. We're gonna skip over all of this because we reviewed all of that last week. And today, I'll put the links to the documents so you don't have to, you know, you can do real-time editing on your own machine. Thank God for modern technology. Um, so this picture right here, that's the provisioning phase. And I wrote step by step.
I don't think you're sharing
This
your
Uh,
screen,
picture right
Mark.
here, you're not sharing, and we don't know which one
I'm
you
not
mean.
sharing my screen. You're absolutely correct. I will fix that immediately. Sorry about
Just,
that.
just to note, folks, that I won't necessarily be here for all the call. I wanted to pop round and see if there's anything that I could be doing, should be doing as well. If I head out later, I apologise, but at least I wanted to show my
Uh,
face.
we have a new face on the call, Francisco. Would you like to unmute and introduce yourself?
Yeah, sorry. Some of well, I know Mike. Coincidentally participated in a collocated event in Linux in Amsterdam. It was, yeah, I think it was Amsterdam or Vienna. I cannot remember. It's too many things on the last over the last year. I'm from Open Nebula Systems. I'm kind of new here. We are evolving to a general membership. Apologies for the repetition. And yeah, basically, we're trying to be more into the confidential computing ecosystem. So
Yeah.
that's why I'm here trying to understand a little bit better and a little bit more. So I'm in silent listening mode.
All right. So again, the links are in the chat. Let me know if you don't have them. I can resend them. So this is the provisioning phase. I do not have a screen to put both of them side by side here. So this is a line-by-line description of what is happening at each point in yeah in the document. So, oh, sorry, in the swim lane. So please review. let me know if you want to make any changes. Otherwise, we'll accept them and move on to the next one. Just check for all sorts of things, like correct capitalization, correct use of terms, lack of ambiguity, extra content that you don't think should be there. Also good to know.
Yeah, so I think that's one major thing which came up from the work I was doing that I exposed in the TAC on AVSs. You're assuming all of the policy lives in one place, and that is not always going to be the case. So I kind of looked at two ends of the spectrum. In that one is the AVS owns all policies. So for all workloads, you ask the AVS to say whether it's good or bad. The other end, the owner owns all policies, including everything down to is this appropriate firmware, microcode, etc. And then there's a middle case where some of it is owned by the AVS, and that might be the lower level stuff, maybe UEFI, maybe up as far as the VM image, and then the stuff on top is owned by the workload owner.
Mike, I would need to put a pin in it because in this flow there is no AVS. The verifier is in the credential acquisition phase. That's the next one. This is where the keys are placed in the key store and the credential is generated by the credential authority. And this is before the workload even attests itself.
Okay. All right. Okay.
Okay. So I'm putting a pin on it. I'm not disregarding what you said. We will handle it once we get into the second part where the AVS is involved. Okay. So, all right. So again, let's just go voting. Like review 1. Let me know if you'd like anything to change. If not, we'll move on to 2, and I'll just go through the table this way.
Hey, Mark, does this involve any attestation at all in the provisioning phase? You are saying no, right? Like the workload.
Yeah, the workload is not even running yet. Right? So this is where all the workloads, they have not even started. They will start later and they will all share the same credential and signing key. Right? So there's no verifier here. We're just pre-creating it.
There is no prescriptive way to define the workload, right? It's up to however you generate your X509 or bit. It's up to the
you the workload owner decide what that identity will look like. In fact, so if I have workloads running in Germany and France and I care about location, I will be creating different credentials for German workloads versus French workloads. This is what this explanation, like I want to basically make sure that somebody reading this gets the full picture.
And the security domain would basically be the SWID, right? The URL.
Correct. Okay, so once everybody is okay with step 1, we're going to move on to step 2. And I'm just going through like capitalizing identity because workload identity is one of our predefined terms.
Mark, one quick question. Is there any categorization of this workload identity that we need to account for? Maybe that was the point that Mike was bringing up, but I'm not sure.
So this is where I say the identity must include all the attributes of the workload the relying party would need to consider in its authorization policy. That's the impedance match. Like I don't say like, however you want to structure it, let your relying party tell you what it needs to be.
So can I just also say that the thing you're editing on screen is not the thing you sent a link to in the chat.
Wait, let me re-link you, okay?
Sorry.
So chat. So document under review. That should be it. Try it. I may have made a mistake. All right, if one's okay, can we
No,
move
no,
on to
that's
two?
still not the right one. It's not what
Well,
you're showing on
how
the
can it
screen.
not be? I don't understand this. I'm literally pasting the URL from here into chat.
Well,
Okay,
okay, go to the
try
top of
this.
that. Go to the top of.
Try this. If you go to our top level Google Drive, just select the document called Try Profile for Whimsy.
Okay, so I don't have access to that. I'm not part of.
If you scroll down, I think Mike, I can access it, and it's the
I
same.
scrolled all to the bottom, and it's not there from the thing that is linked.
That is weird.
The KLV4 thing. It says TWO profile for Whimsy. What's at the very top of your document? Arc. Yeah, okay. I see that.
It's probably
But I
user
get
error, dude. Like, look, scroll past the first diagram, and then you'll see this page.
I go to the first diagram and I get step and notes with nothing in it. It's all empty.
That is so weird.
Maybe I need edit access to see it.
Oh, refresh the page.
I've just refreshed the page. I'm asking, who am I logged in as? Let me try logging in as someone else.
Okay, let us continue. If one's okay, can move on to two, and Mike will handle you as soon as you're ready. The workload owner precomputes the reference values that expect the workload would receive from the verifier during remote attestation. Now, this is a little tricky, but this is how you put the access policy on the key later, right? Because eventually the verifier is going to come back with some reference values, and those reference values are going to go to the key store, and the key store needs to basically, that is what it needs to connect to.
I do not understand why you say that it expects the workload to receive reference values from the verifier.
What I mean, correct. So in the acquisition phase, there is a point where the workload goes to the verifier and requests attestation, supplying evidence.
Yes.
Okay. And that evidence is going to compute certain attestation results.
Yeah.
And those attestation results are the ones that are going to go to the key store. And they will be matched against the wrapping key access policy, such that the wrapping key can be re-encrypted for the workload and sent back.
Okay. But the reference values should not go through the workload.
Attestation results, not reference values.
You wrote reference values in the text.
Oh my God. Attestation results. Great catch.
Okay.
Thank you, Manu.
You're welcome.
That was a brain fart. Okay. This is why we have reviews.
Yeah.
Okay, Sudar and I have the same problem.
Okay, let me see in my Gmail. Like, can you request access or something? I mean, this makes no sense. Why?
I have a request for access.
Okay, I'm opening it up right now to see if I can grant it. There you go. So you have a share request.
That would be interesting if you actually need to have, editing rights to be able to see the edits of others. That's kind of weird.
It's yeah. Let me.
Which one? I'm trying to work out which one I requested access. I've got so many different.
Manu, I granted you. Or sorry, Mike. I granted you access, editor access.
Okay, see if it changes. Yeah, I can now see it all. That's very weird. Seed operating is the same.
Okay, well, send me a request. I will do. Is it resolved for you now, Mike?
Yes, it is. Thank you.
Okay, great.
So one more question: the attestation results then as signed by the verifier then, if they flow
Attestation
back.
results will be, yes, attestation results will be assigned by the verifier. So how, this is actually kind of a question, like how do you even know what those attestation results are going to be? Because if
Right.
you don't, so it's a,
Yeah.
this is what Sudar's prototype is going to help us figure out. But so far, I see no better way of doing it.
Okay. I think you have.
Expect the workload to receive. You cannot say expect the workload would receive.
Yeah.
Yeah. Should or will receive.
So it's still to receive.
Yeah, that works.
Yeah. Okay. So if 2 is okay, let's move on to 3.
So the intent of 2 is to configure the key release policies, right?
Correct.
During
That
acquisition
happens
phase.
later.
So Mark,
Yeah.
still on 2. Why is it important in this step to talk about the fact that the workload is receiving this, as opposed to saying that the workload owner pre-computes the attestation results, that the, what is it, the key store, needs to unlock the keys or the material. See what I mean?
That, yes, I see what you mean, and maybe we'll to do that. That it, uh,
I think it's more important that the unlocking, right, is
yeah,
that
that
the fact that the workload is conveying that information is just, plumbing.
correct. No, you're correct. I'm just looking for a way to rephrase this because that's great feedback. So attestation results that the workload would later present to the key store in exchange for the CWK.
Good.
All right. Would not later, would present to the key store during the acquisition phase. That's better because
Yeah.
why say later when we can say exactly when?
Yeah.
All right, so we're okay with 1 and 2 now.
Yeah.
All right,
For now.
going once, going twice.
Hey, Mark, one quick question, right? Like
Uh-huh.
the way to generate this attestation result is you basically have to run within that confidential compute and then get the evidence and call the verifier to get the
We're
results.
deliberately vague on how. Okay, in fact, if you want, I can specifically add that this specification is deliberately vague on how this would be done.
Well, if we start talking about the things that we are being vague about, then I would argue that in our world, where the verifier, the key store, and even the acquisition of the policy or the reference values, all of that is, automated. Then the workload the workload never gets the
Yeah.
attestation
So
results. So do we
for
want to say that we're
you,
vague about
if
that
it's
too?
that significantly a difference, I mean, this is a difference in degree, not kind, but like when the degree gets large enough, I would just say, put your own swim lanes in here.
Okay, got it.
Yeah, like let's do another profile for you. And this is where we want to review that pull
Yeah,
request that I put in the agenda.
I remember your feedback. Yeah.
Yeah,
I remember your
make
feedback.
sure that your mechanism is also covered by one of the variants that they are talking about.
Yeah. As
Okay,
I mentioned, it's the bandwidth and the focus and what we can, and I'm
I
not going to fight
understand,
with Whimsy
but
at this point. Yeah.
yeah, right. So the workload, so number 3, workload owner now sends the workload identity from step 1 and the reference and they're not reference values, the attestation results. To the key store. It expects to receive back from the key store a wrapped CWK and to a credential request that it will subsequently use to request the workload credential from the credential authority. And again, if you have any concerns, otherwise we'll move on.
The workload owner is actually receiving those things, I guess, to provision them then on the machines and all that good stuff to do the.
Correct.
Okay, got it.
Yeah, but there's nothing here that's secret.
That's right.
Okay. So this is where we're requesting it. We're not talking about how it's done. So the next step, somebody commented on securely.
It's
Uh,
me. I hate it when people use that word.
yeah.
Sorry.
Well, we can drop the word.
Oh no, we just need to see to mean what we say. So I put yeah. Are we talking about mean that it's tamper proof, tamper evident? Well, there's no tamper proof. Is it the
well,
confidentiality or the integrity or the availability that we care about, right?
okay, so how about this? Let's say for here, the key store generates a new CWK. Okay, and I will update the text to say it's generates CWK. So here, down here, we have the mermaid
Well, I actually that
stuff.
you want to persist it, right? So you do
Oh,
want to
we will later. We will later.
Okay.
I just want to say like generate a CWK. Bear
Okay,
with me
that's
here.
fine.
We will store it in a minute. But we're just generating new CWK. I will just accept that. And now the key store sets the CWK access policy.
So actually, just to say, if there are particular policies as to how keys should be generated, we should say the key store generates the CWK according to policy blah. If it's implicit, then we don't necessarily need to. But if we want to make it explicit, we can do. Does that make sense?
Well, so it is correct that you you must always generate the keys in accordance with your company policy. Like, and there's a number of keys that are generated here. We can make a blanket statement basically saying, all key generation policies, key strengths, and algorithms must match a particular organization's policy.
Yeah, if we don't think it's worth
kind of
doing, that's
implicit.
fine. Yeah, no, that's fine. Okay, let's leave it. Then I like it as it is.
Okay, so the key store, here's why I just moved it. The key store stores the CWK and sets the access policy to the value of attestation results it has received in step 3. And then I basically claim for security reasons, the CWK access policy cannot be changed once set.
Okay, so we need to define what we mean by cannot, right? I mean, it must be prevented from being, or do you see what I mean? Cannot's a dangerous word here.
Read-only access policies actually want to make perfectly clear. Once you create it, you can only read it.
I think it's overly restrictive, Mark. What you want is you want to make sure that for different workloads you have different CWKs, but if you update the same workload, you may still want to have the same
If you update the
CWK.
workload, the attestation results will change.
The attestation results.
So
Yeah,
the risk
but then you can update the reference values to the
just
key store.
regenerate the key if you're going to do that, right? Because here's the thing: the danger is if I can change the access policy on the key, then I can execute an insider attack where I will basically say, I, the administrator, the control panel, who has no business knowing the key for this workload, will temporarily change the policy so I can get this key, or malware acting on with my credentials can change this key. And then I can change it back, and hopefully the audit doesn't catch it.
Yeah.
And then I just stole the key.
Got it.
Whereas if I say this key is tightly bound to these, like, I mean, maybe we can specify the security reasons. Like, I can put them in the security considerations.
Yeah, so I think indeed the concern there is that if your policy setting and access to and changes to the policy are done outside a TE, then you have a risk of an insider attack on those things. And the reason I was reacting to it is because in my mind, it's all of that should actually all stuff that is upstream to the workload should itself be done in TE so that there is no
Ideally,
access.
but it's like,
Understood. But then it's important indeed to add to the consideration that this is a hole in the security model precisely because there could be an insider attacking this thing. This is a gap in the security model that we're trying to equip a workload with credentials that nobody else has access to. And what we're saying is that upstream of that workload, there is something that could break that security promise that we do to the workload. That's all I'm arguing about. And I agree with you. It may be the current implementations and all that. That's fine, but we should indeed mention that in the security considerations.
Yeah.
And with that addition, I'm fine with number 5.
All right. Any other? So I have a comment on policy. I have a question, a comment on cannot. Let me see. Mike, let's see what you said. Define. Okay, how would you like me to define access policy?
No, that's not the bit that I'm asking you to define.
It's cannot. He wants to know
Did
if
I?
it's, yeah. No, it's the cannot. Yeah.
It's the cannot that. Oh no, I do have a define on the policy. That was supposed to be on something different. I apologize. It was supposed to be on securely down there. I don't know what's happened there.
Okay,
so
I can
please remove that one.
I can
and I'll add it to there.
Done. Okay.
Yep, you can. Yep.
Cannot be changed once set. Well, so as I said, because I'm going to specify what the security reasons are as a footnote to the document and the security considerations, I'll just reference it here. And then somebody who, if they want to know why this
but cannot means two different things. It means that because of the way this happens, it is impossible for it to happen. Must not is great. Yeah.
Gotcha.
That's fine. Sorry,
No. This is you're doing exactly what this review demands. So perfect. Number 6.
Hey,
by the way,
Mark,
number 5. Anybody?
Is there any concern on 4 around the firmware or hypervisor changes could potentially impact the measurements? Like,
well, this is your evidence to attestation results mapping policy. And this is more for deployment configuration, right? So you basically want to make sure that you allow for a range of changes that you're comfortable with, but we're not going to talk. So again, we can have a conversation. We can have a section. I would be perfectly happy to add. So how about
I think one answer to your question, Sudar, is if the firmware and white code changes, then yes, you'll need to create a new measurement. That I think is what you're asking.
Allow
right?
some flexibility.
But then would the measurements be part of the policy, right? Yeah. I think we should be cautious to not.
So that's what I'm putting in here, right, Sudar? Under deployment considerations, how flexible is the mapping for evidence attestation results to allow some flexibility without having to reauthorize all workloads? So I'm just putting it in here so we can revisit this. So we're not losing track of your comment here, because it is a deployment consideration, but it's not sort of something that the swim lane needs to worry about. All right, number 6. Key store generates and securely stores the CSK and stores. I'll just say stores the CSK pair. Let's not even go there. All right. Any comments on this? All right, then I'm accepting. Number 7, the key store encrypts the private portion of CSK with the CWK. And I think that's uncontroversial. I will accept that unless there is some. Going on to step 8. The key store uses the workload identity supplied in step 3 and the CSK generated in step 6 to create a credential signing request. Well, it's a credential signing request, I guess. And sign it with the private CSK. I usually capitalize private CSK. All right. We're okay on 8? All right. So then the key store returns to the workload owner the wrapped private CSK generated in step 7 and the credential signing request generated in step 8. So again, pretty straightforward stuff. The workload owner forwards the CSR received from the key store in step 9 to the credential authority to request the workload credential. Again, I'll accept because unless okay, just go ahead and scream if something's wrong.
So hold on, because the workload owner forwards the CSR received from the key store to the credential authority to request the workload credential.
Yeah. Right. So now we have a CSR.
Oh, to
It's
sign.
basically
Yeah. Okay. Got it. Yes.
signed proof of possession with a bunch of workload identity encoded inside.
Right. Okay.
Yeah. Okay. 11. The credential authority generates and signs with its own CA issuer signing key the workload credential based on the CSR it has received in step 10. I can even say trusted by the relying party. That's the binding, right? The CSR doesn't need to be signed by anything trustworthy. It's just signed by the private key that was just generated by the key store. But here we're saying, okay, now we're issuing a credential that the relying party will trust because it tries to CA issuer signing key.
Okay.
Okay. Any comments on 11? All right. We will delete the back. Thank you, Mike. The credential authority returns the workload credential to the workload owner. And the workload owner makes the wrapped CSK the workload credential available to the workload. All right.
So
should I
what's
say
that? There's a
private
question. There's a
CSK here or no?
Say again.
It's a private CSK. I mean,
so the question I had was, does that need to be done over an encrypted channel? I've lost track exactly of what
does not
what are
need.
those. Okay, that's all. That's fine.
But we can do, we can do security analysis. Do we actually need TLS for this? I mean, it doesn't hurt, but I do not think this protocol requires it.
No, that's fine. That's good. In which case, that you can remove my. I will remove my thing. I just wanted to check. That's good. That was my assumption. Just worth checking at this point.
So thank you for that. I will write the security considerations with the what was the policy why we cannot change the access policy. I will update the mermaid chart, separately. Let's now move on to the acquisition phase. I don't know why there's an extra page here. All right, now we're in the acquisition phase. So again, you can open it up for your own document. We're just going straight for the write-up. And again, let's go through them. This is the duplication of step 13 from the previous diagram. So the workload owner supplies the workload with the plain text workload credential and the wrapped private CSK.
Why are you adding?
This is the point.
Why are you adding private? Because the CSK is a signing key, so it is private.
Yeah. Well, it has a public portion too, and the public portion is in the credential. It's an asymmetric key, so it still has private and public.
Yeah, but it's the signing. Oh, okay, so I thought
CSK is asymmetric.
CSK is symmetric? No.
It's asymmetric. It's an asymmetric.
Yes, I understand, but the S is the signing. For me, the signing portion has to be the private. So that's why signing and private seems redundant. But CPK would have been the public version of or the public part of the C.
But then we need to define yet another term. So
never mind. Yeah.
Okay. So the workload inside its T. So basically here, Mike, you should not have an objection to securely.
I always have objections to securely because
so how would you rephrase it?
I probably would lose the word securely there at all. You put it inside the TE, so that's kind of fine. Securely is. It doesn't mean anything.
Word.
Securely means nothing, right? It can mean so many things that it means nothing. So I would just remove it. What you mean is according to policy, which we've already said is redundant.
How about that? Inside,
Okay.
how about this? Inside its T, the workload, I'll just
Yeah, that's fine. I'm cool with that. I had no problems with the words inside the TE. That's fine.
You do have a problem or you don't?
No, I do not.
Okay. I'm just making it clear here that nobody ever sees the CDK other than the workload.
Yep.
Okay. Number 3, workload generates evidence about itself and its hosting environment for remote attestation. The evidence must include the public CDK, the public portion of the CDK generated in step 2. Okay. The workload contacts the verifier and presents it with evidence generated.
This is where I get interesting. Okay, so
this is your policy comment, right?
How many workloads do we think that JPMC will have running at any one time? Thousands?
Eventually?
Yeah.
Hundreds of thousands.
Yeah. Okay, right. So are you going to use question 1, which is kind of side issue to this, is are you going to be expecting that using one verifier for all of that, or will you possibly have an internal verifier for some of those, or multiple internal verifiers?
I would imagine that verifier here is a stand-in for a giant mesh of trusted services that individually speak to different parts of the infrastructure.
Okay, but it's one component doing the verification, right? So,
well,
but I think
it's like saying that AWS is one component. It's a cloud. It's a distributed.
No. I don't mean that. I don't mean that. Okay. Would you mind letting me share my screen? I think it's an important thing. So I'm sorry to bore on about this, but this is stuff that I think is important.
You always have good insights. So let me stop my.
If you could unshare, there we go. Right now,
yeah, go for it.
And then, right, I'm not going to show all of the slides here, right? But that's a starting point. Okay, so let's say that you've got on the left you've got a workload on a host, right? On the right you've got the relying party. In the middle you've got a station service. What we're calling a verifier here, right? On the right we're calling this the workload owner. Same, different words, same thing, right? So it may be that the relying party has the best view of what this information should be, but the AVS will probably have a better view of this. It may not be that the relying party always cares about this. It may delegate this information here, right? And I think that the relying party should always control policy for all components, but it may wish to delegate it. Okay. So the question here is, where is policy applied, right? So option 1 is that all policy is applied in the attestation and verification service, right? And if you have tens of thousands of different, not instances, but let's just say 2,000 different workload attestation measurements, right? And you generate another 100 every week because you do CI/CD, right? You're going to have to make sure that this verification engine is up to date with all of those at all times, and that's very onerous indeed, right? Alternative is that some of it you keep here, and you do that verification yourself. So you're actually splitting the verification here, right?
Okay.
So
I already know what I'm going to say to you, but I will let you finish.
Okay, so that's fine. So and it could be you could split it wherever you want, and there's some reasons for delegation and some reasons against delegation, right? And my suspicion is that this is what the world really looks like. Yeah, you've got multiple. That's JPMC. That's HSBC. This is some Morgan Stanley. This is all of these. Okay, and you have multiple verification engines, and it's just like a huge mesh of different things, right? And we've got. I did a bit of pretend UML modeling because I hadn't done it in 20 years, and I thought it'd be fun, right? So the point really being that it may be that the verification is not a single entity, and that actually you split it into multiple ones, and that has an impact on the trust relationships, but not on the process probably. All I'm thinking is that we may want to specify in your document that the verifier is not necessarily a single entity, and that's kind of where I think it should be.
So I had a conversation with Peter Castleman. So he is the principal of the Spire, whatever they call it these days. And it's in the context of whimsy. And there is an underlying assumption underpinning this particular reference architecture, right? That underlying assumption is the following. Now, it may be an incorrect assumption. We can change the assumption. I'm just telling you what it is, how the document was written, and sort of it may make it, we may need to make it more explicit. But when I update my workload from one thing I consider good, or anything about the workload, that the firmware, the hyper, whatever it is about that machine with that thing running on it, I can update it from one version that I trust to another version that I consider good, or I shouldn't say trust. One thing I consider good to another thing I consider good. It could be an upgrade, it could be a rollback, but I can change it from one thing that's legit to another thing that's legit. And the relying party does not change at all, so long as whatever the workload corresponds to that identity in the minds of whoever thinks what a payroll application is. The relying party doesn't. In fact, it doesn't even change if I used to run it in a legacy container, and now I decided I'm going to run it in a confidential container. Even that change, the relying party does not know or care.
So we said you've just said two different things. One is that it doesn't know or care, and the other is it doesn't change.
It doesn't. Well, it doesn't know or care in that when that change happens on the workload side. So say maybe the workload now changed what is considered to be its correct default configuration, or maybe we upgraded the firmware on the host where the workload is running, or we fixed a bug, or we updated, we fixed a security vulnerability.
So the workload creator makes a change, and there we change the attestation measurement. We need to update policy to say that this one is now good and the other one is now bad, possibly. So there's a revocation step there.
Maybe not. So for instance, here's
maybe not, but at least we need to update that the new one is good.
If you have to update the key access policy, which is part of the provisioning that we just went through, then you need to reissue the credentials to the workload.
If the attestation measurement has changed, you need a new policy to say that that is now
the attestation results may not have to change if the change is not security sensitive. So if you didn't fix a security vulnerability,
no, that's incorrect. That is incorrect. The attestation measurement will change if there is a single bit changed in any of the.
The evidence will change for sure, but the attestation results need not. The evidence will change. I absolutely agree with you. The
attestation measurement is the evidence signed.
Evidence signed. This is what presented to the verifier, right?
Whatever. Yeah, and so the measurement is the evidence signed, which means that if the evidence changes, the measurement changes.
If the evidence changes, the attestation results may not have to change.
So Mike, there's a disconnect here between you two. Is that
there really is? Yeah.
The evidence is presented to the verifier. In the RATS model, the verifier then creates attestation results. The verifier may say, aha, the evidence has changed, but I know...
Okay, all right, okay, right, fine, okay. Evidence goes to measurement. Measurement is verified and comes up with the result. Agreed. But the policy around whether that new measurement leads to the same result needs to be updated. Yeah. So, and
So
this
attestation
is
results. I would figure that if the goal
uh,
is to prevent an older vulnerable workload to get access to some data, you would need
yeah, this is
to.
irrelevant to the point I was making. I think, as far as I can tell, this is orthogonal. So what I was trying to get, I'm not saying this isn't important, right? But I think it's orthogonal to the point I was trying to make. The point I was trying to make is that policy needs to be owned, and the verification may take place in two parts, in two different entities. So the verifier may actually be two different entities in different trust domains. That's a key thing.
So trying to
You
understand how
might, for
best.
instance, decide that you trust the financial regulator, probably not, but let's say, to give you a verification result on the microcode and firmware and UEFI of the workload. But you may decide that JPMC's verifier is going to be the one making a decision about the workload itself, for instance.
So generally what happens is with regulators is the demands the regulators make are fairly
Okay, I shouldn't have said the regulator. It wasn't the regulator wasn't the important bit.
They will
What I'm
say
just
the
saying is you may split it. So
Yeah,
it may be you'd say the CCC it has an AVS, right? And you're going to trust the CCC to do the verification of the lowest levels of the stack. But when it comes down to it, you're going to have a different verifier, which may be within JPMC. It may be a trusted third party who does the rest of the verification. So all I'm saying is that the verifier may be in two parts, and we need to think about whether we care about that in the definition here.
So I would have to say that normally what the regulator will want, or audit or whatever, I'm bringing it back to that because this is where this is who you're accountable to. Okay.
Yeah.
They basically say, show us that you have policies in place, and then these policies are followed. Okay, just tell us that you thought about the problem and that you did something about making sure it doesn't become a bigger problem. So if our policy is basically our policy could be, so long as it's not a CVE above 9 vulnerability, we will patch our software but not up the security version number. That's our policy. Because if it's not remotely executable vulnerability, we will patch it within whatever, right? And so long as that our policy and that policy doesn't violate any rules, and we can illustrate that this policy is being followed, that is sufficient for us to pass a compliant audit. Now, if somebody gets super paranoid, they can tighten up the policy and they can basically say, oh, anything above CV3, and I have to reissue my workload credentials. You kind of,
again, I haven't managed to explain my concerns here. My concern is not about changing the policy. It's that different parts of the policy may be applied by different. The verification may be a multiple part process with policy split and different parts of the policy applied by different verifying parties.
And I think that is a correct statement, Mike. And that's the conclusion that we reached in our infrastructure. And that's why we said the two verifiers that may exist in separate places actually
maybe more than two.
Come again?
Okay. Maybe more than two, but carry on.
Yeah, exactly. Absolutely. In fact, we see a whole chain of verifiers. There's many verifiers, but that those verifiers must themselves, if both party, if Alice and Bob want to know that they can continue to talk to one another, that all the verifiers that are involved in verifying all the pieces that go into making a decision as to whether or not they can talk to one another must be part of the same verification network. So they must be recursively verified so that you know that the verification decisions that are made in different places all abide to at least the mechanics of doing the verifications, and that the injection of policies in these different verifiers are themselves,
I think I'm happy with that.
being verified. Because what's interesting in everything we've said, Mark, all along, right? We say the workload owners does this and the key store does that, and we put this data here and there. All of those are workloads, right? The bits don't move from A to B, from the key store to something else. All of it is pieces of software that are moving data from A to B or C or D. And so eventually, for any of those verifications, composite, that's why we talked about composite attestation, composite verification mechanism. You must have all the different pieces, the bits and the verifiers themselves. All of them must be verified. So anyway, I just wanted to drop that there because I agree with Mike. I agree what Mark is saying because I've been trying to follow the exercise here.
Oh yeah, no, I agree. I agree with everything Mark's saying as well. But I don't think that any of the things that he's saying addresses the point that I was trying to make, and that's one
So
concern.
there is a gap in the middle. Essentially, what you're saying, Mike, there's a gap in the middle. If verification needs to be split between multiple verifiers, then how do you know that the other verifiers are complying to what you expect those verifiers to do? Right?
Yeah, and I'm not even particularly worried about that. I think we just need to state that there must be multiple verifiers, and therefore there needs to be policy around the verifiers. But
to achieve what Mark wants to do, is that if Alice wants to talk to Bob and Alice is changing according to the latest and greatest from the workload from the Alice owner, right? If the owner says Alice is compliant and is doing the right thing, what he wants is that Bob doesn't have to know. Bob shouldn't change. Bob and Alice should be able to continue to talk so that Alice and Bob.
Yeah, I 100% agree with that. 100% agree with that.
If you want both of those things to be true, right? What you're saying, Mike, and what Mark is saying, then what you have, all verifiers must be themselves part of a single verification network, so that you can automate those verifications and cascade that down, so that Bob doesn't need to worry about it.
I think we need to be careful about the word network here. But there needs to be a chaining possible. But yes,
exactly. So, totally.
Typically, what will happen
a cryptographic network, a virtual overlay network.
Okay.
Typically, what will happen when we run our services in Azure is there'll be a policy around what constitutes a properly patched server, which is completely determined, run by Microsoft, right? If we didn't like it, we would have to host our own data center with our own policies, our own management. But we will trust them to manage the server, the hardware, the firmware, all of that. And now we manage our policy around what constitutes payroll app for us, right? And those policies, they will independently change. And so long as basically say, look, part of my policy is I just need to run on something that Microsoft considers good. I'm not delving into the details of what they consider good.
Yeah,
it's an attack vector, but we trust them, right? And then I just manage my own CI/CD pipeline and the reference values that come out of that.
Yes,
you can
that.
expand it to the arbitrary level of complexity, but at least there is that separation.
But the reason the complexity matters here, I think, is that you may have chained verifiers, right? And I don't care about exposing the policy question. I think it's an interesting business problem that Sudo's going to have to worry about in the future. But I think we need to be explicit that the verifier may be bipartite or multipartite, and that this has impact on things like signing, or may do, which I notice isn't here, which I'm happy about. Do you accept, Mark, that there may be multiple verifiers?
I both accept it and I treat them here as a single endpoint, right? So I go to the verifier and I get some reference values. Attestation results. And it could be in a more general sense that I had to go to multiple verifiers and combine the attestation results from them into some blob, right? But the impedance match point is evidence gets exchanged for attestation results, broadly speaking. Maybe there are multiple parts of evidence, maybe there are multiple parts of attestation results, but as a blob, there is a blob of evidence, there is a blob of attestation results. The blob of attestation result goes to the key store. The key store says, are these good attestation results? And if so, here's your CWK.
Okay, I think I will be happy if we have a note which says a verifier may in fact be multiple verifiers in a chain or federated manner. Because if we do that, and we're sure, because when we do other levels of detail, that may have impact. Like, for instance, if we have that's cool. I think we'll be fine at that point. I think that's all we need to do.
Oh, no, that's
Manu,
fine.
do you think that covers it for now?
We can add a section to the document, sort of to the deployment considerations. Again, like we just added something based on Sudar's input, right? So we can basically say, yeah, and when we talk about evidence, we mean the collection of evidence from hardware and software and this and that, and your GPU and your whatever. And then we talk about attestation results. We talk about this potential network of federated verifiers that individually, analyze different parts of evidence, but they gave us back this bundle. Like we can talk about that.
No, that's fine. I think we do that. I want to make Sudar aware of the operational complexities of this, of deciding which bits of policy sits where and who keeps control of it and all those sorts of things, and which bits you delegate, because there's lots of delegation issues here.
Especially when those workloads end up being
right?
agents.
One is on the evidence side. If you want a multi-part evidence, then we have to worry about like, hey, what is the authority, right? Like if JPMC has its own set of evidence
absolutely, yeah. So that's absolutely part of it. I mean, in the end, JPMC is the arbiter of which bits of evidence to accept. Sometimes it'll accept evidence because it's from a party that is trusted in this context. Sometimes it will accept evidence because it's got its own reference values that it cares about. And it's fed policy and said, for me, for JPMC, I'm not accepting it. I won't accept a yes unless this microcode version is up to 13.62, for instance. On other occasions, it may be, well, we're happy to accept whatever Azure says is good for a microcode version, right? Or it may be we're happy to accept what a third-party attester says is good for that. But then, of course, you need to think about the trust in that third-party verifier, because that's a great attack vector if I'm if I want to be attacking JPMC and the rest of the financial world. These are the sorts of things I think we need to be concerned about from an operational point of view. Sorry, Mark, I've rather derailed your conversation.
No, that's fine. I want to make sure that the document is of sufficient quality that we can all agree it's what we want to say. So it's all these inputs are actually invaluable for that. So
that's very kind.
Well, we have 2 minutes left, so I guess do you want to stay on the line real quick so we can finish the this one last stretch, or
let's just try to get the end of step 13, see if we can.
Yeah, unfortunately,
I'm not seeing anything else I don't like.
Okay, well, Manu, you can do it offline then. Let us just finish this. So
see you guys.
Yeah. All right.
Thanks,
Thank you again.
Thanks.
All right. Bye. How do I share? I need to share my app. Sudar, thank you for all your feedback as well. It's just gonna finish this. Okay. You should be able to see my screen right now, right?
I can't. It's black at the moment. It's there now. It's fine. It's fine. Got it.
Okay. So the workload contacts the verifier, presents it with evidence generated in step 3.
Yep.
All right. Verifier appraises the evidence received from the workload in step 4. We're not talking about failure cases, so of course it can decline.
Yeah, absolutely. Yeah,
verifier computes attestation results based on the evidence.
Yeah.
Verifier returns attestation results from step 6 back to the workload. The attestation results must contain the public portion of the CDK from the evidence, clearly. The workload forwards attestation results received from the verifier in step 7 to the key store, requesting the unwrapped CSK. The key store validates the attestation results against the CWK access policy. Already talked about that. Key store encrypts CWK with the public CDK and the attestation results. The key store returns the encrypted CWK to the workload. And again, no TLS required because it's all.
Yeah, absolutely. No, I agree.
The workload decrypts the CWK with its private CDK. That decrypts the wrapped private CSK. You need to capitalize.
Yeah, no, I think it's all good. It's a very good description. It's really nice and neat, this one.
Okay. So then we're done. and then I'll see you guys next
Cool.
week for more.
Yeah, so
deployments of the
Sridhar,
version we
may I
can discuss.
just say that this sort of conversation around attestation verification service and the operational side, I'm trying to expose within the CCC. It's a socio-technical organizational issue.
Absolutely.
It's multi-partite, and so as we have these conversations, I absolutely want JPMC to be involved. You're exactly the sort of complex organization with multiple workloads and multiple everythings that I want to be involved. So as I move into that, I'll get in touch with Mark and ensure that the right people are being invited along. I suspect you're one of those people. I'm trying to work out how to have that conversation at the moment because it's really important.
Yes,
so thanks
absolutely.
for your time.
I've been beating the deployability drum for some time now. All right.
Absolutely.
Thank you all.
Thanks, folks. Appreciate it.
Okay,
Thank you.
have a good day.
Bye.
Bye-bye.